Hello, everyone. My name is Cindy Lopez, and I will be presenting the amino acids. This is the first topic for our individual presentations, number 2. So let's go ahead and get started. So just to kind of give you a little bit of background, I'm just going to kind of explain what the different structures of the amino acids. So there are 4 basic components that make up an amino acid: a carboxyl group, an amino group, hydrogen atom, and an R group, which is a side chain that kind of pops out of the amino acid. Uh, all of these are attached to essential carbon known as the alpha carbon. Within each amino acid, which I believe there are 20 for in proteins, all the R groups are going to be different, with the exception of glycine, which only has a hydrogen atom, so it doesn't have an R group. And then each amino acid is going to be abbreviated by 3 letters specific to that amino acid. And here I'm going to go ahead and draw out an amino acid known as proline and kind of mark the 4 different components on this that are listed here on this presentation. So proline looks like this. I'll go ahead and start marking for you. Here's the actually right here, proline. And just to kind of give you like its structure, so that you can have an idea of what the whole thing looks like, I'll go ahead and just write it out completely. So we'll have CH2 here. And then now I'm going to go ahead and just label everything so that you have an idea of what's what. So over here, just this is going to be the carboxyl group. This right here is going to be your amino group. Over here is your lone little hydrogen atom. I'm going to do H atom. And then this section right here that I'm marking off is your R group, or that chain that I mentioned earlier on this slide. Moving on, there are a few different types of amino acids. So they're going to be nonpolar amino acids, uncharged polar amino acids, and charged polar amino acids. The nonpolar amino acids are going to be hydrophobic, while the charged and uncharged polar amino acids are going to be hydrophilic. So back to nonpolar amino acids, there are going to be 9 total in this group. And then some examples for this group are going to be glycine, leucine, and tryptophan. For uncharged polar amino acids, again, it's hydrophilic. There are 6 amino acids in this group. And then some of the examples are serine, tyrosine, and glutamine. And then for the charged polar amino acids, again, hydrophilic, so water-loving. There are 5 in this group. And then within this group, there's like subcategories. So there are going to be 2 that are acidic or negatively charged, and 3 that are basic or positively charged. And some examples of these are aspartate, lysine, and histidine. I'm going to go ahead and kind of talk a little bit about the synthesis of amino acids. for our assignment, we had to create a pentapeptide that ticked all of these categories, I guess, that needed to be included. So the amino acids that I used are valine for the nonpolar amino acid, serine for the uncharged polar, uh, lysine for the positively charged, aspartate for the negatively charged, and then the cysteine, just because it was on there that I had to use as well. So basically, when you synthesize an amino acid, you're forming peptide bonds. And that happens when a water molecule is removed. The carboxyl group, the C is left over, and then it forms a bond with the amino groups N, and that's basically how you link each amino acid together. So here first, you can see this first group here is actually going to be valine. So I can mark it here. This is valine. And then this here is going to be serine. And you add these two together, and when they're synthesized, you get this group here. And this CN bond, carbon-nitrogen bond, is going to be that peptide bond that formed. And then you get a leftover of H2O that is just going to be, like I said, your leftover. Moving on, you get that full chain already. So you can see up here, this is the chain from last time. Just for simplicity's sake, I just put R1 and R2 for your R groups. Because if I wrote out the whole thing, it'll take up the entire page. And then I added lysine, which is this group right here. So lysine, this is lysine. I added it together. Again, you do the synthesis, you get rid of the water molecule, and then you end up with this second bond, and this is your new whole amino acid that you get. And then it kind of builds off from there. So just to kind of emphasize this, moving on, you have your already made amino acid. So this will be the one from the previous slide, plus aspartate, which I'm having trouble pronouncing. And then you do the whole synthesis. Again, you get rid of this water molecule, and then you end up with another peptide bond. And then you get this nice big structure here. And then finally, moving on, I did that whole group again before and added the cysteine, cysteine. And then you do the whole synthesis here, and then you end up with this nice, beautiful structure here. And again, that CN bonds are going to be your peptide bonds plus your leftover water molecule, water. And then from there, you get this nice, beautiful pentapeptide, where you can see here the peptide bonds are highlighted in yellow. The N-terminus, which is your terminal amino group, is on the left, highlighted in blue. And then your C-terminus, which is the end carboxyl group, is highlighted in green. Thank you so much for listening to my presentation. If you guys have any questions, please leave any comments. And I appreciate your time for watching this video. Thank you.